continuing with work we were doing with dealing with rational expressions, if we want to identify the least common denominator of two rational expressions, there's a process to follow. First thing we want to do is factor each denominator completely, write any repeated factors as powers, list the different factors, and then if the denominators have common factors, use the highest power of each common factor. So if you want to find the least common denominator, first thing you do is factor each common denominator completely, then you list the factors, and then the least common denominator is going to be the product of those factors. So in part B here, when we factor this, it will become x minus 3, x minus 8, and we also have x minus 3, x minus 3. So the different factors we have here are x minus 3 and x minus 8. Taking the highest power of x minus 3, which is coming from here, it's going to be to the power of 2. Our LCD is x minus 3 squared times x minus 8. So when is the LCD of two rational expressions not equal to the product? If a factor appears one or more times in each denominator. So when a factor appears one or more times in each denominator. So if we want to find the LCD, least common denominator for these expressions, for this denominator here, we can factor out an 8 of x minus 3. 8 we can rewrite then as 2 cubed, and then x minus 3. This denominator here, we can factor out a 10. We're left with x minus 3. 10 factors to 2 times 5, x minus 3. So our LCD, the factor of 2, we take the highest power, which is 3. And then we take the 5. And then we take the x minus 3 to get a least common denominator of 40 times x minus 3. And this one here, we can factor out a 15. We're left with x plus 4. And then we can factor 15 into 3 times 5. This term over here factors to x plus 4, x plus 5. So our least common denominator, you take our number terms, they're just 3 and 5. And you take the other factors, x plus 4 and x plus 5, to get our LCD of 15 times x plus 4, x plus 5. So we're going to use these now to add and subtract rational expressions. So first thing you want to do is factor your denominators, figure out where your expression is not defined. Okay, those are the problem areas in your domain, in your denominator that x cannot equal. And you want to find your common denominator. So you'll take your least common multiple and you'll use that. Rewrite the expressions with a common denominator by multiplying both by the appropriate form of 1. Simplify and add, and simplify further if you can. So problem B here, first thing we want to do is factor in the denominator. So we have x and then x minus 5. So identify where the expression is not defined. First expression is undefined when x is 0 and when x is 5. The second expression is undefined when x equals 0. So when we find the common denominator for x minus 5 and x squared, we take the highest power of x, which is the x squared, and then the x minus 5. So we have to get the common denominators of that. The first term here, if we want this as our common denominator, we're missing an x. So that means we'll multiply by x over x. The second term in the denominator here, we're missing an x minus 5, so you multiply by x minus 5 over x minus 5. So you do that multiplications, and then you combine like terms here in the numerator. So here we have 2x cubed minus x cubed will leave us with 1x cubed. Subtracting the second piece, so the signs are all going to change. So we'll have a plus 2x squared plus 19x, and then minus 20 over x squared times x minus 5. Since none of the factors of the denominator are factors of the numerator, the expression cannot be further simplified. Okay, so we want to add these expressions and simplify our results. So the first thing I'm going to do is rewrite this negative x squared over 1, just because I know I'm dealing with these as fractions. So I'm going to turn it into a fraction. When we think about the excluded values, that's if we set 1 minus x squared equals 0. That's going to give us values of plus or minus 1. And our LCD, since our first term just has a 1 in the denominator, there's no restrictions. So our least common denominator is just going to be the 1 minus x squared. So that means our first term, we need that in the denominator, so we'll have to multiply by 1 minus x squared over 1 minus x squared. We're adding these. Our second term already has that as the denominator, so there's nothing extra we need to do there. So when we multiply there in the numerator of the first term, we'll end up with negative x squared plus x to the 4th. And then we'll add the 1 that's in the next term all over our common denominator, 1 minus x squared. So from here, we're done. Probably could rewrite it in standard form by power x to the 4th minus x squared plus 1 over 1 minus x squared, because we can't factor any further from there. We also want to subtract these. So we got to do this the same way. We're going to end up with the same terms here. So we'll have the 1 minus x squared over 1 minus x squared times the negative x squared over 1. This time we're subtracting 1 over 1 minus x squared. So when we do that multiplication in the first term, we'll end up with negative x squared plus x to the 4th, and then we're subtracting the 1 from the second fraction. We still have the 1 minus x squared as our common denominator, so writing it in standard form, x to the 4th minus x squared minus 1 all over 1 minus x squared. Number 8 here, we're going to add and then subtract these and simplifying. Again, we're noting the excluded values. So excluded values here in the denominator, we set 4 minus x squared equal to 0. We get solutions of plus or minus 2. And in the second equation, if we set that one equal to 0, we'd get an excluded value of 2. So that one's getting doubled down. Our values here is x cannot be plus or minus 2. Now, this first fraction, the denominator can factor into 2 minus x. It's difference of squares. 2 minus x, 2 plus x. So that means our LCD, you'll notice the second fraction already has 2 minus x in the denominator, so it's included in both. So we'll just need to have 2 plus x, 2 minus x as our LCD. So we won't have to do anything extra to the first fraction here, because its denominator is already good. However, the second fraction here, we're missing a 2 plus x in the denominator, so that's what we'll need to multiply by 2 plus x over 2 plus x. When we do the addition, we've got the x squared, and then we're adding, multiplying 1 times the 2 plus x will get us values of 2 and x. And then our denominator, we said, was 2 minus x, 2 plus x. So putting it in standard form, we've got x squared plus x plus 2 over 2 minus x, 2 plus x. When we subtract, we'll have x squared over 2 minus x, 2 plus x. We're going to have the same value that's up here, except we're subtracting this time. We've got to subtract the quantity. It's going to end up being then the 2 plus x over 2 minus x, 2 plus x. So that means we're going to have x squared minus x minus 2, and we already wrote this in standard form, and 2 minus x, 2 plus x. In the next video, we're going to simplify this a little bit more to get our final answer.